Our last problem asks us to find the difference in the angles of refraction for red light and violet light. And you can see that there are different n values for the flint glass, both in red and violet light. So we're actually going to go back to Snell's law for this one. We're going to figure out those angles of refraction for each of those colors. On the left is where we're coming from. That's the flint glass. So I'm going to put in the n value for the red light. And I know that my angle of incidence is 30 degrees in either case. My n value for air is just 1. And I'd like to know the theta, so I'm going to leave it in there. The first part, I can plug it all into my calculator kind of in one go. 1.66 times the sine of 30 degrees. And I get 0.83. I'm going to drop the 1 at this point because anything divided by 1 or multiplied by 1 is just what it was before. So I'm just going to say sine of theta sub r. But I still have to get rid of that sine, so I'm going to do the inverse sine of both sides. And I get 56 degrees. Now I have to do the same process for the violet light. So remember the left-hand side before was what it's coming from, it's the glass. So my n value is changing to 1.70 times the sine of 30 degrees still equals n sine of some value theta that I'd like to know. Sorry, this n is 1 because we're talking about air. So the first part, the left-hand side, I'm just going to plug into my calculator 1.7 times the sine of 30 degrees. And I get 0.85. Just like last time, I'm going to drop the 1 at this point because anything multiplied to 1 is just itself. So the only thing I need to do to get my answer is take the inverse sine of both sides. And I get 58.2 degrees. So we can see with our red light, we have a smaller angle than with our violet light.